Hi, this is Alex from devstories.eu. Scikit-image, the AI image pipeline, episode 2 of 5. The most common silent bug in computer vision AI is not in the neural network architecture, it is a data type mismatch. You feed an image into a model, the code runs without throwing errors, but the outputs are complete garbage. This happens when your libraries fundamentally disagree on how a pixel should be represented numerically. Today, we will fix this by covering speaking the same language, Dtypes and OpenCV. In scikit-image, images are stored as standard NumPy arrays, but the numbers inside those arrays behave differently depending on their exact data type. The default format from webcams in standard image files is 8-bit unsigned integer, known as uint8. These values run from 0 to 255, where 0 is absolute black and 255 is peak intensity. However, scientific image processing functions and deep learning frameworks almost always prefer floating point numbers. In scikit-image, a float image expects pixel intensities to be scaled on a strict range, usually from 0 to 1. Here is the key insight. Do not use NumPy's asType method to convert your uint8 images into floats. If you take a uint8 array and simply call asType float, NumPy only changes the underlying memory type. A bright pixel value of 255 merely becomes 255.0. It does not rescale the values. If you pass that array into a scikit-image function or a PyTorch model that expects maximum brightness at 1.0, the math explodes. Your whites are suddenly treated as if they are 255 times brighter than the maximum possible value. Instead, you must use scikit-image's built-in utility functions. The most important one is called img as float. This function checks the input data type and handles the mathematical rescaling automatically. It safely compresses a 0 to 255 uint8 range down to a precise 0 to 1.0 float range. Data types are only half the battle. You also have to align the color channels, especially if you're capturing video. If you read a frame using OpenCV, it hands you a uint8 NumPy array, but OpenCV has a historical quirk. It stores color channels in blue, green, red order, known as BGR. Scikit-image and most modern AI models expect red, green, blue, or RGB. If you forget to swap the channels, red apples look blue, and human skin looks completely alien. You do not need to call a heavy OpenCV color conversion function to fix this. Because the image is just a NumPy array, you can use basic array slicing. You slice the array across its 3 dimensions. You take all rows, all columns, and then for the final dimension, representing the color channels, you specify a step of -1. This tells NumPy to step backward through the channels, reversing BGR to RGB instantly in memory. Let us walk through a complete ingestion pipeline for a deep learning model. First, you grab a frame from an OpenCV video stream, giving you a uint8 BGR array. Next, you reverse the color channels using NumPy slicing to convert it to RGB. Then, you pass that array into img as float. The array is now a floating point matrix, perfectly scaled between 0 and 1.0. Finally, you convert this clean NumPy array into a PyTorch tensor. A neural network cannot tell you when its input data is scaled incorrectly. It just learns the wrong patterns or fails silently. Controlling your data types and channel orders right at the ingestion step ensures your pipeline rests on a solid mathematical foundation. That's all for this one. Thanks for listening, and keep building.